I guess it's time to start. I want to be on time because I have 60 slides prepared for you. I guess I need to skip some of them. So don't hesitate. At any time, when you say, okay, that's something I'm interested in, I want to talk more about this, raise your hand. I'm glad either to answer your questions directly or we can meet afterwards. I have enough of my cards with me. So you should not leave the room without any question unanswered. That's my goal for today, okay? Monitoring is a big topic, at least for me, because I'm, or better said, I was, in the SUSE IT team lead. So one of the major goals of such a team is provide the services all the time, 24/7, to our lovely customers called developers. And you know, you never can have uglier customers like developers. It's everything easy, everything works. My laptop is easy, so why shouldn't it work on its head? Okay, I will show you a bit of that, what we learned over the 6 years when I do the job, and also want to show you some ideas, and at the end I want to show you something more. Let's see. So first start with me. I started with SUSE in 2003, helped to develop. So yeah, I am guilty. I'm also a bit of a developer. The SUSE Schul server. Then I helped the openSUSE education project since today. And I was the team leader of the internal IT since last month. And now I switched over to a new team that's called DevOps. So DevOps means what you can imagine. I cannot imagine much about it at the moment, but we will see. Our main goal is currently the build service. And even that beast has to have some monitoring, I guess, to be available. So my main responsibility since I started with IT is to provide the best services and to produce our products. Means SLES, means HA, and all the stuff that is flying around there. And that's why I'm giving that talk. Since a while, I'm responsible for all the crazy little monitoring applications and packages that you see in the SUSE build service and that you see on the products. So if you have any question around a monitoring package, I'm guilty. Okay. But why we are here for, Markus? Default, Entschuldiger, yes. In German we said that. So what's the topic for today? Monitoring is not important, at least if you ask management. Because what an IT team has to do is control your infrastructure. Yes, okay, we'll do that, no problem. Next point, optimize our IT resources. Squeeze out any bit of it. And then you stand there as IT team lead and said, sorry, how can I do that? So the question is, how can I do anything that upper management requires from me without knowing any of the requirements I have for my current resources? So the idea is, in the end, to say monitoring should be the basic requirement that you have. If you ever start from scratch, leading an IT team, if you ever get into the situation that you are an administrator, think about what you miss right in the beginning. And to 99% it's monitoring, right? Most of them that I know say, okay, I'm administrator. My monitoring is user monitoring. Whenever they call me, I know that something is wrong. Works. Trust me. If it works for a long time, I don't know. Depends on your company. Okay? So I will try to help you a bit, get an idea what I mean when I say, okay, become reliable. Become the good guy of your company. sometimes it turns out that management asks you, what are you doing all the time? Our IT just runs. Okay, that's something you have to live with if you implement all the details. No, that's just a feature I need to monitor, you know? When I see that this one reaches the end, then time's over. Okay. First, give you an idea about SUSE monitoring packages. Who is using SLES? Who not? Just was a control question. Okay. Tips and tricks. Give you a small insight just on the slides. I will show you how we inside SUSE IT set up a high available and even scalable monitoring with our own packages. And if I find the time, I hope so, I will show you some demonstrations live, online, via VPN, connected to the story of the SUSE company. And in the end, I hopefully can ask you some questions because I'm not sure. I have some ideas, but I need your feedback about how SUSE should go with monitoring. Anything you want to add to this agenda? Otherwise, I will start with my 60 slides. Okay, so SUSE monitoring packages, that is what we have, what you know. Up to SLES 10, we always had Nagios or Nagios, however you call it. I guess you know Nagios Enterprises sitting here in the US, doing a great support stuff, doing everything they need for their customers, and they started to protect their name. That was the reason why there were many forks of Nagios, and there was also a fork of Nagios plugins. That was one of the reasons, not the only one, but one of the reasons why we decided to switch over to Isinga, which is a fork of Nagios. Don't be confused. It's easy to switch over from Nagios to Isinga. Under normal conditions, and that means even for us, it means installing the Isinga package, renaming the etc Nagios directory to etc Isinga, and renaming etc Isinga Nagios conf to etc Isinga Isinga conf. RC Nagios stop, RC Isinga start, migrated. Yeah, they are completely compatible. You can even switch back somehow. So don't be confused of that. And monitoring plugins is a rename of, haha, what a surprise, Nagios plugins. So the monitoring plugins that we ship will automatically obsolete the old ones. There should not even be something that you mention. They will be installed at the exact same location. Everything should be the same. And now to something completely different, openSUSE. openSUSE has the build service, and inside the build service you have many repositories. So we have a server monitoring repository with currently more than 600 packages just for monitoring. Over 600 packages. If you're done with testing them, you know what you have done. Thanks, I did that. We have newer packages, even newer Isinga, even newer monitoring plugins, and so on. A lot of add-ons that you can use, but all of them are with no support. You need to contact the packager of those packages directly if you run into problems. The funny part is, yes, I use them heavily, so it might happen that you get a fix before you even notice it inside that. And who knows about Package Hub? Maybe because that's one of the new teams I lead. Package Hub will do the following. It will use some of those packages from here put them over in a repository, in a new one. So all those packages will see a review of SUSE employees, and it will be integrated in the SCC. So don't be surprised when you see inside the SCC or on your machines that there is a new repository after that SUSECON that's called Package Hub. Packages in there will have no support, no official support, so be warned, but your SLES will be fully supported. It's just that most of our customers ask us, can I have some of those packages without that stuff? I need to add some repository, I don't know which one, and so on. So that's why we invented now the Package Hub. And a benefit of all SLES customers, we will keep the old versions of the packages. So when you update, you find out, ooh, the new version is something crappy, just roll back and you're done. Questions? Good. So, I told you in the beginning, monitoring starts before a machine goes online. Normally, we start even setting up the MAC addresses on our Pixie server when we order a machine. And you can even start monitoring if the Pixie server already issues those MAC addresses. Monitoring without history will not help to think about the future. So if you know that your CPU load is going over the top since 2 years, and you need to order new machines, then it's easy, right? If you don't know what's going on your machines, you have to guess. Not a good decision for enterprises. Monitoring without graphs and trends is hard to understand. I will show you later what that means. But simply as that, if I show you the direction, you know what I mean, right? If you see the disk filling up and you see the graph of the disk, you don't need to think about what you need to do. If you need to compare your Excel sheets, that's a bit harder. So what can we monitor it? Just to give you an idea, I had people that I'm talking with really monitoring those devices. I had people, and that's real, I had people monitoring their bees with a Raspberry Pi. If the weight gets higher, you know, you have to go there and earn your honey. Simple as that. They even monitor the temperature inside. Yes, you can check your coffee mug, check for housebreakers, and the funny part is you monitor what should be there or what is there. Think about a CMDB. You define inside your CMDB what should be there. Please use your monitoring to check if it is there. If you have a CMDB, talk to your monitoring guys. Hey, do what I want and check it. So please use monitoring to ensure that services and states match your model. Something that comes from development, something that is highly encouraged in DevOps. Yeah, we have models and we ensure that the models match our systems. This is what you monitor. Point. What can be checked? Everything. I told you already, coffee mugs, bees, yeah? And now your question should be, how? That are the only rules that we have. Give us some exit codes. That's all. Choose whatever programming language you like. It can be a scripting, it can be C++, it can be Lua, it can be whatever. The only thing that Nagios, Isinger, and all those other tools need is one of these exit codes. And if your programming language doesn't deliver such exit codes, write a wrapper. Done. That can be checked by any monitoring tool around the world because all are Nagios compatible, at least. So all you have to do is provide a script that does exactly that. And if you're gentle, and I know all of you are gentle, you can provide some additional output on standard out. So the administrator is not lost. Why is this service of critical? But again, that's not needed for the monitoring itself. The monitoring itself relies only on the exit code. Please keep that in mind. And I told you graphs, trends are important. They go regarding monitoring also to standard out. Who's developing plugins? Who's writing some of them? Know about that URL? Perfect. And again, that is compatible with all the monitoring systems I know. Maybe you know some additional ones, but I'm sure they are Nagios compatible. So this is how it can look like. It's bash. Yeah? And the only thing that is important here are the exit codes. That's it. I could skip out all those echoes here without any problem. My monitoring still would work. Who knows what that script is doing? I told you in the beginning, check if a local file exists. If it does not exist, everything is okay. So we use it to check if a log file exists, for example. You can even do event handling. Who has heard about self-healing machines? You can try that out. Works somehow. For me, the question always is, if I try to automate, for example, a restart of a service, maybe I should look first why the service at all stopped. But that's up to you. You can build self-healing services just with your monitoring. As easy as that. The monitoring will do the rest. After 15 seconds, that's a default. State is going into critical hard state, and then you will connect to the remote machine and say, hey, restart my service because it's down. Easy as that. Active monitoring. What does normally happen? The monitoring server actually goes to the client, and now it's end. Everything okay? Okay. Next client, everything okay? Everything okay? That's active monitoring, that's active noise cancellation. So that's what the monitoring server does. And all the way that it takes for the monitoring server to go to those people, do the handshake, saying, yes, hello, how are you? I'm your monitoring server, what's going on? Takes time, right? Takes resources. So while active monitoring is more or less the only way to see if something is really alive, and the best way to do it in the way of your users, because they are doing the same, it may happen that your monitoring server is overloaded if you have too many active checks. That's why we also have so-called passive monitoring. That means Markus will tell me every 5 seconds from now, I'm okay. Okay, perfect. So the monitoring server just has to listen. Huh? And it works, yeah? So he answers, everything's fine. Until that happens. Because if Markus is dead, probably he cannot raise his hand anymore. So if your service dies and you have a passive check of it, you're gone. You will not notice. So you can define and live grateful with passive checks, but if you do that, keep in mind, hey, please check my freshness, if that guy is still alive, or if the service that gets the information is still alive. SNMP, old, but still useful. So SNMP version 3 has encryption, has personal users, has everything you need to make the service itself secure. If the service itself is secure, of course, and we have many, many, many interesting critical security updates for SNMP, but nobody uses. How many people use SNMP? How many use SNMP version 3? Okay. Please think about having an own network separated just for that SNMP stuff. I know network switches, storage devices, they still use it, but keep them secure, have an own network. You can use extend to execute scripts via SNMP. Get the return values. You can use SNMP to execute Nagios plugins. And then you use an SNMP walk to get the output. Possible. So you don't need any other service running. NRPE version 3 also allows you to use SSL encryption with certificates on each host. Something new, something the Nagios community is waiting for 25 years. Now we have it. So SNMP traps, passive monitoring. Devices send out, my disk died, and now I'm dying. SNMP walk, I'm the monitoring server, going to the guy asking. Okay. Questions around that? No. Perfect. That's a graph from our internal monitoring just to show you why you should have dependencies. What will happen if that switch here behind dies, or if that switch dies? Those are switches, right? That's the monitoring server. That switch dies. I have a problem with all of those machines. And you will be flooded with information about down systems if you don't have that dependencies. Please, even if you have just a small monitoring setup, always define dependencies. You will not know in front, but trust me, latest after the first network switch downtime, you will be very, very glad that you had defined that. So, what should be monitored? Two different views. Administrators, please keep it in mind. Your manager doesn't care about the hard disk is failing. Me as a manager just interested in, can we still run our shop? Yes or no? Right? Question from you?
So the dependencies help you to nail down the root cause much quicker.
Yes. So dependencies, if I get from the monitoring system the information that this switch is down, this is just one message for me. And if I log into the system and I see, okay, this switch is down and all the other nodes are unreachable, that points me directly to the problem. But if I get all these machines are down, it's like a denial of service. I get hundreds of messages. And you just need to pick the right one. Does it answer your question? Okay. So, that's the view that you as administrators want to have. Seeing all the services, okay, DNS server number 1, DNS server number 2, HTTP, my mail server, and so on, right? That's what you want to have as administrator. But be honest and tell your chef, hey, come on, we also have a business view just for you. I know counting is always a problem inside management. That's why we reduced the number of checks here just to have a few to show you, okay, the shop is still online, you know. You don't need to have all the details. You just need to know that one. And yes, business process monitoring is available inside Nagios, Isinga, and all those monitoring tools. You just need to set it up. It's a bit like dependencies. So if I see that one of 2 DNS servers is down, how does it affect my shop system? Not really, right? If one of 3 mail servers is down, the only one who needs to care is the administrator. So hopefully this will always stay green. But because of that, because it always says green, you should present it to your management, right? Please do. They will be happy, very happy. Trust me. Okay. Going back to the administrative part, what should be checked hardware level? Everything in hardware level. I know the picture is not that good, but you know that all the PSU units are missing here. Normally I say everything that is rotating should be checked. Hard disks, fans, PSUs, everything. And in the worst case, as you can see me here sitting down, trying to find out where the air conditioning unit is, even that might be a good check, right? RAM usage and ECC errors, for that, please analyze MCE log. There are different ideas out in the market. They say you can use different tools just for RAM. But SUSE is collecting all hardware errors in one log file. So there's not really a need for you to have different checks for different possible hardware errors. CPU problems, MCE log. RAM problems, MCE log. The only thing that you don't cover is hard disk failures. I don't know why they put them in there. Maybe because hard disks fail too often. I don't know. CPU load, disk fill rate, network bandwidth, blah. Standard, right? Who is monitoring his hosts in that way? Just a few. Who is doing not? Or who doesn't know how to do it? Okay, I will show you in a few seconds. So, people asked me last time, how can I monitor my shop system, right? And I say, okay, what are you currently doing? I monitor if the Apache process is up and running. Perfect. Do you know that the database is down since a week? Yeah. It doesn't help. It does not really help. So even I'm currently working towards getting all that Apache checks moved out from our monitoring because they are senseless. If the PHP app is dying, what will your Apache check tell you? Yes, it's still delivering something. We get response code 200. Perfect. Thanks, Apache is up. There are tools outside, and that's just one example. There are a lot more that try to use your shop system, your online services, as a normal user. So they log into the system, for example. They buy some pieces in your shop. They check, for example, oh, that's a wiki page, I'm sorry. They check, for example, your basket, and then they delete it again. And after 1 or 2 minutes, everything starts from scratch again. It's crazy to set up. You need to learn something new. It will take you 1 or 2 days, trust me. But when you have that, you are a hero. Because this is something that you can provide to your management, and you can even point to the developers and say, come on guys, here we have, for example, okay, I have my state login. I can log in very quickly, so these are the response times. And then I choose a random page. Can you see how long that takes to choose a random page? Developers, please fix the application here. Skip login. Fix the application in that part. Or here, delete a test page. Even takes so long. Why? Please fix it. That will make your management happy because it makes your users happy. They will benefit from monitoring. Isn't that crazy? And if you have developers in-house, ask them what they use to test their software. Most of the time, what I do is ask them, what are you doing? Yes, we are using Jenkins. Perfect. Because you, when you have to keep the application up and running afterwards, can use the same stuff. You can use even Jenkins to do something like that and measure the response time of the applications. And when your management comes and says, hey, our users respond to us that they need to log in 5 times more than 1 year ago, you can say, yes, I have it here. But that's not my fault. Even development needs to step up and make it faster, or we need more resources. Right? SSH checks should return at least the version of the SSH server which is running on the other side to make sure that the login is possible. Email checks. Think about sending an email and checking from the other side if that email is in the mailbox. Just testing that port 25 is open does help nobody. Okay? Hardware checks on the machine. No discussion. Everything else from a user point of view, and users don't check for open ports. Not really. Next point, notifications and escalations. What I always do is for notifications, where is the trainee? What's his handy number? Because he's so motivated, he's happy to jump out on Saturday night, right? Because the SSH server is down. Okay, time periods, escalations. So if the trainee doesn't answer, maybe it's time for the one who is his tutor to get the notification. So I would just simply step over. If you have an idea or want to ask something, you can see and get the PDF right after SUSECON. It will be available on the download page. Or if you don't trust them, give me your card, I will send it to you. MRTG, yes, we're still using that old stuff because we set it up, I guess, 15 years ago, and I just want to keep the history. In our times, normally you put it into some monitoring stuff too. But it's nice. That's an important point, monitoring the I/O on your machines. So I just put the command here so you can get those nice graphs. Reads, writes, delays. That's what you want to know, right? So if you have virtual machines, who's using KVM, Xen, or other stuff like that, virtualization-wise? Do you know how many network traffic do your machines produce over the virtual interfaces? Do that, because then you may know when your virtual server is running out of bandwidth, which of these virtual machines running on that server produces the problem. Okay, and in KVM and even in Xen, it's easy. You just need to define a name, and then you can run MRTG and use SNMP to query. Simple as that. Open source, works. Monitoring SQL servers, I guess that's easy. Just remember, the monitoring stuff doesn't need to have write access to your database, right? Not a good idea. Postgres, monitoring Postgres is more hard. Often the Postgres process needs to have, or the Postgres check needs to have super user privileges. Who? Think about SSL encryption, please, if you do that. Or check on the local machine. Oracle, the same. Some values can be just retrieved if you have the super root access. Talk to them. Ask them if that can't be made easier. And there's, of course, more. So what do I have here? Something that's very important in at least my team. It's always happy if you work on something, disable notifications. If I install a new server, probably there will be some outages marked by the monitoring system. So instead of setting that single machine offline, disable notifications, come on. Next Monday, your boss is standing in your office. What happens over the weekend? Nothing. Sure. I get no notification. So I have a cron job. Every day, enabling notifications again. Same happens here. Who knows about the NSCA? Not the NSA, NSCA, Nagios Service Control Acceptor, or whatever it is called. We're talking about the passive checks in the beginning. That daemon is receiving those passive checks from the clients and feeds them into Nagios or Isinga. But as I told you, if the daemon is down, nothing will happen. So even that, monitor those daemons that run your monitoring. I have a third machine outside of our cluster just pinging and checking if the monitoring is still alive. Normally it happens just once, and then you know your mistake, right? Okay, just some more package recommendations before we come to some demos, and we are, well, at the end of the time. Monitoring plugins, Zipper. So if you want to know about how many security updates, how many recommended, how many optional updates are missing on that machine, that's something you want to do. If you want to know if somebody installs a package which is not officially supported by SUSE, that's the one you want to use. It will tell you exactly, okay, those 5 packages from the 3,000 you have installed on the machine are not supported. I run that check every day on all our machines. Monitoring plugins NSCA, monitoring plugins bind. So that will produce some very interesting DNS statistics. You have to do something around bind and named, of course. At least they need to write a log file. Mailstat, the same. SSL certificates. Who is using SSL? How many of your certificates have expired? So just what we do, we put the public ones in one directory and run that check every day. Easy as that. And then you know, oh shit, web server needs to be updated in 2 weeks. Okay, just do it. And this is something I want to show you, the checkmk agent. And of course, if you're having an SAP system up and running, monitoring plugins SAP Health will do a lot more than any of your consultants will know about SAP. You have to walk with them through the configuration, but after that, trust me, SAP will be very interested in your data because you know a lot of performance data when you install that plugin. Okay, demo time. I wanted to show you how you can automate your inventory. Normally you use manual work. Who's using an automatism like Salt, Puppet? I'm lost already. So, but I found something new and I want to show you what you can do. Here is my local host. So if you start Isinga, normally you get that. That's localhost, my local laptop here in front. That's the standard which is checked, right? There's not much, and you have to check everything manually. You need to configure, you need to sit down, you write some service definition files and stuff. Oh, nice. Okay, let's enhance it a bit. And now I need to jump to the right machine, that's my one. And you can say, I'm root. Root is always good, right? There's a package called checkmk agent that you should install on your host that you want to monitor. It's a very, very small package. If you look at it, it's not that big, not containing much information. But once you set up the x-inetd and configure the right one, so only from this machine, that's your monitoring machine, x-inetd is running, you're done. On the monitoring machine itself, you add a new host. So this is how it looks normally in the beginning. All hosts is empty. And I'm just going there and say, okay, I enable localhost right now. And I do my inventory. Check MK, do an inventory, and be verbose so we see some output, okay? I skipped that one, I will do that later. But this is an automated inventory which is there right now, generated already by this script. You can even see what that script does is by executing the script itself. So this is your server. It's a bash script. You can look into it if you like. If you call it on the machine, this is the output. And what the monitoring server does, ping on that port, get the output, and put it into your monitoring system. So right now, I configured my monitoring system. That's done automatically. And the only thing you need to configure in the end is your monitoring configuration and enable the directory where all the automated checks are put into. They are separated because of a reason, of course. So I compile again, now with that directory in mind. Look down, reload here. And now you see there are a lot of pending checks. Really a lot of them. So all my file systems are automatically checked and detected. How many of you had a problem that somebody added a new partition or a new file system and didn't inform the monitoring, right? Auto discovery. Run it once a day. You will never ever lose a partition. Even the temperatures, if it detects temperature sensors, they will be here. How many TCP connections do I have? Oh, I'm running a MySQL database on my laptop. I get information about the mount options, and so on and so on. Okay? And everything is done via one check, check MK. That's the only active check that is executed. And the monitoring will make sure that everything is fed into the right place. So once that check is executed, I hope everything will go, yes, green. And you can have a look on the load of the machine. How much is my CPU? Oh, I need an old laptop, an older one. CPU utilized, what is going on, and so on and so on. So you see, you get many informations, even about caps, queues. Oh, I have a problem with my slave. Oh, I'm not connected, that's a problem. Even ping, okay. Ping of my localhost is not so important at the moment, but you get the point, right? So, and right here, I go to the next point, trends. That's the file system usage I have. That's the growth of my file system. So you can see sometimes I'm probably downloading ISO images or delete them. And here's the trend. So it looks like I need a new hard disk in a few years, yeah, because the trend's going up. Questions about that? Ah, by the way, and if your management asks, how is it going? Yes, sir, here is the PDF, just for you. Print it out, make them happy.
So that was quite a few different checks you're doing on local hosts. You have a whole network over it. That's a lot of checks that you're putting out there. You report back to a single point. Are you suggesting installing this on all of your servers, or how do you get that escape that checks that?
So as this check is a simple bash script, you can also check that via SSH, of course. And this is our internal view. So at the moment, in Nuremberg alone, inside development of SUSE, we have 648 machines that are monitored, and we run 7,500 checks. And if you look here at those pictures, I just scroll a bit. I hope you can see it better. Those are passive checks. So here's an NTP check that says, okay, I have no information about the stratum. That is coming from that checkmk agent. You can even roll that out via salt or whatever, because it's so simple to configure on the client side. You have to do something on this monitoring side, of course, but the client side is install the package, maybe open the port if you have the firewall, and configure X-initd, done. Yeah, but these are currently just the problems that we have, for example, inside Nuremberg, and some of them, yeah, are clearly coming from that checkmk, saying, okay, your mount point here is going full, and then you see the trends, right? So it looks like somebody is cleaning up regularly. Might work. Some of you have seen that one. checkmk, it's just another front end for your monitoring. Who knows about Isinga 2? They also have just different front ends, right? In the end, all the monitoring systems doing the same. That checkmk front end is using the same database that I use on other sites. I don't know if you know about Nagvis. You can put some pictures in the background, and then you can place your machines on top. So that I know, okay, here we have build hosts, which is red. So probably there are some build hosts which are currently down. And that's why the whole check is going red. Or I can go here and say, okay, what's here with the ops backend? The ops backend has a security update pending. Oh, what a surprise. Okay, but this gives you in one nice view that you also can show on a dashboard an overview of what's going on inside your systems. You can even have something crazy like that. That's just a picture, but I guess you get an idea. Picture of a rack, and when you know which machine is going where, hey, you can even have a webcam putting the pictures in the back end. And you have a trainee that always puts those little icons in the right position. Okay? Questions?
Where is the graphics data stored?
The graphics data. You mean that one, that picture in the background?
No.
The other ones?
The other one.
Okay, we're speaking about something like that here. They are stored as an RRD file on the monitoring system. Right now, in our case, for example, as we have so many service checks and all of them are producing some graphs, and we are going back 5 years in our history, we use SSDs. Because even with running RRD cache and everything in the back, it's just too much I/O for a normal SATA drive. So if you run Isinga or Nagios and you reach a total amount of 2,000, 2,500 checks, be prepared that the latency of your checks is going up. Nagios, Isinga are just single-threaded applications using one CPU, not more, on your systems. So it doesn't help if you have a 60-core machine, because only one is used. And what we use here to have that possible is that we have a load balancer on the machine. That brings me back, if no other questions there are, no? But that brings me back to the presentation. Let me see. Yeah. So first of all, we have set up a cluster for our monitoring, because we say if the monitoring is down and you don't know about the state of your machines, not good, okay? So what we have pacemaker and chorusing, which are part of the high available extension. So you have the basic hardware, a database, some storage in the back end. You have pacemaker and chorusing checking those devices. That's an independent monitoring. And we have all the services on top that are managed by Pacemaker and Coruscant. So Pacemaker knows if, for example, the database changes, I probably need to reconnect the Apache. In simple cases, restart in the worst case. Okay. Basic rules for our HA setup. If a service is implementing high available on its own, don't jump in with Pacemaker. Please, not. Because if you have a MySQL cluster, a Galera cluster, and now you jump in and say, and I want to manage that with Pacemaker, you start the trouble, right? DHCP, it's 10 lines of configuration, and then you have 2 DHCP servers running independent. Named master-slave setups. Oh, what's the problem? Postgres, always. So if those services come with an own HA configuration, leave them untouched, please. Don't jump in. Services that can run independent on the node, for example, in our case, that's the Apache or the module that puts all our data into a database, leave them running on both nodes. They don't need to be stopped and started and stopped and started each time when the node's pushed over. No. And have a third node at least for quorum. So we have 2 hardware nodes and 1 virtual machine. Just to make sure that if one is flaky, at least those 2 can make a decision. If you have just 2 nodes, 2 hardware nodes, of course we had that a long time, then if one gets flaky, what should the other one do? It doesn't get a quorum. So your whole HA cluster, it's getting crazy. Put another virtual machine, 2 gig of disk space, maximum 512 megabyte of RAM, just to have Pacemaker up and running and telling the node that lives, yes, we are the ones that survive. Shut the other one down. Okay? Don't make our mistakes. Yes? Well, the problem is normally that if you have just 2 guests and one is losing, for example, 1 network connection, then the other one can say, I have still all the network connections, I can take over, but he is not sure. Because it may happen that he is losing the network connection, right? So it's better to talk to a third person if you are unsure and say, can you please check if I'm the right one who survives? And then the third person will look at the one who is down and saying, I'm sorry, I cannot reach him either. So we both agree that we are the masters. Yeah. That's the principle of HA. No, the virtual guest is completely independent on our virtualization cluster. I'm sorry. I'm sorry. I'm sorry. That's something I missed to tell you. Yes, of course. Yeah. So in real, it's 3 hardware machines. No, it's even more, but I guess you get the point. Okay? Okay, what we do, and that's the setup that was shown here on the page. Coruscant Pacemaker, DRBD, to switch over those graphs, you were asking for it. So we have 2 SSDs in each node, running DRBD, syncing each other, and just one is always the master, because that's the one who's running eSynca. We have mod Gearman for load balancing, which is a nice thing. I just agreed with an update of that stuff today in the morning. Mod Gearman is just simple as that it's a job manager. You can feed in jobs. That can be build a package. You know Jenkins and stuff? On the same machine. Both machines run a Gearman server, which is the job server. And both machines run so-called Gearman workers. And workers can do more or less everything. So that was the reason, as we run more than 2,500 checks, our latencies went to the top. Once we implemented that, we are down to less than 1 second latency when you execute a check, which is, for monitoring, acceptable, I think. So I will show you later how that works. CheckMK, that's something I showed you already. This is something we use for the automatism. Inventory of machines. MRTG, Yes, for that old stuff. And lots of other add-ons. If you want to know more details, just ask me. I can say you which packages and how to configure. So that are all those project pictures in place that are installed on the two nodes. Again, the third node just has, just has this one. It doesn't do any service other than pacemaker. So I tried to have that split it somehow. So this is one node, this is the other node. Those processes are running in parallel. And probably those here in the middle are run and managed via pacemaker. So how does it work with mod Gearman or the Gearman server? We have a single, we could have chosen Namon or Nagios here as well. So Isinga said, okay, please execute something, a check. We have Nagios event broker modules that are compiled with the right code of Nagios, which are shipped by us, by SUSE. So they fit into the running Isinga process, and they can feed a database. So you can have a history of all the events. They can feed into live status, something that comes with CheckMK. I will come to that later on. Right now, I use it for Nagios to have fast results when I open the front end with those pictures in the back. And we have mod Gearman. So information is put to mod Gearman. He said, okay, my local Gearman server, here's a job for you to do. And that Gearman server knows about his Gearman workers. One is local, one is on the other machine. I can set up many, many more workers if I like. And that worker is doing the real check. Returns the data, returns it, done. Can happen multiple times. And that scales, right? So now I can even use 60 processors. With Isinga alone, I can just use one. With something like that, I can scale up to different machines and whatever I like. Okay, that's load balancing. And to make the picture complete, CheckMK is a bit different. So Isinga says to live status, execute a check that is executed via CheckMK, asking X1D, give me your results. And I get all results of the machine at once. There's just one check executed. And I get up to 30 results. CheckMK agent on the local machine, doing all that stuff, and returning the data back into Isinga. And that's it. Saves you a lot of active checks. And that's the way how CheckMK feeds the rest of the information into, via passive checks. Okay, entering Salt. I'm currently in the process of using Salt for monitoring. Isn't that crazy? Who is using NRPE? Who is using SSH? Who is using any other check format? How many daemons do you need to run on your productive systems? If you use Salt for configuration management already, you have a very powerful engine in the back. Because Salt implements the ServerMQ message bus, encrypted already. The trust level exists. And the monitoring server, for example, can send commands to a whole group of minions. Think about web servers. Or to all minions and say, come on guys, give me all your load. One command executed from the monitoring server, asking for something, and he gets a bunch of shit back from all minions. Crazy. And secure. I don't need to think about, because everything about security is done by the salt gurus anyway. So the clients can send the results back to the bus and forget about them. So they don't need to wait when the NRPE can send successfully or the SSH finishes the connection. Send it out, forget about it. Less load on the clients. Reducing the number of running services on the client is always a good thing. So you can get rid of all the other stuff like NRPE and stuff. And even one step further, the scheduler of Salt itself could trigger those checks automatically, completely independent of your monitoring system. Homework to do. At the moment, I'm trying to get that up and running, and I completely messed up my laptop with that. Just to be compatible with existing monitoring solutions. So I think the monitoring server as it exists should do something like the checkmk is doing. Monitoring server, hey Salt, give me the result of the following check on the following machine, using Salt, executing, returning back into the monitoring. Smart. So this is something I hope to get ready next time. Maybe earlier. I know that there are scripts that exist already, but I just need some time to set that up completely. Let's say enterprise ready. Questions about that? You can even do self-healing with that. Some Salt guys told me, yes, we have an event system that can do something. So, as time is running out, just to give you some ideas what's currently on topic. Be relaxed. That's nothing up and running right now. And that's even discussable. So I like to hear your feedback. If you say that's good, I will do that. If you say no, please don't, I will find something else. Okay. People ask me what's next. Oh, sorry. People ask me what's next. Right now we have obsoleted Nagios with Isinga because it's so simple to migrate. And now I'm running into the problem that from Isinga 1 to Isinga 2, that's a way of no return. The whole configuration will be migrated and it's completely incompatible. There is another guy formerly working on Nagios 4, now presents a fork called Nemon. Also nice. There is Zabix knocking on my door constantly, and others that are on the market. I don't know yet what to choose, to be honest. I'm evaluating a lot of stuff, but I want to make sure that whenever we offer something new in SLAS, it's easy to migrate back and forth. That's my goal. Keep it as simple for the administrators as possible, because I'm coming from that, so I know what's going on there. Obsoleting NRPE and NSCA and all that stuff in favor of Salt. That's what I told you before. Consolidate user and group used for monitoring. That would be something I hope to get done soon. At the moment, we followed upstream, always. So if you installed Nagios, you have a Nagios user and a Nagios group. And if you install Isinga afterwards, you also have an Isinga user and a Isinga group. Perfect. Allows you to run both services independent on the same machine without any problem, beside the fact when it comes that both want to write in the same directory. Solvable, not a problem, but makes things a bit more complicated. So I'm currently thinking about using one central monitor user and a monitor group, and probably also a monitor command group for that. So regardless if you install Isinga, Nemon, or whatever comes next, You don't have to change the ownership or set additional group rights. It makes things a bit more insecure because both daemons can write to the same places. So it's a hard discussion with security. I like to get your feedback about that. Provide more monitoring plugins in Package Hub. At the moment, we have around 30 of them, which are not on SLES. So there will be more over the time, but I want to make sure that they just simply work. And most of them that are in Package Hub come with AppArmor-enabled profiles. So if you run zipper and that check zipper command, somebody who breaks in, becomes Nagios, can of course install any package he wants. So I have a Nagios, an AppArmor profile around it that just allows zipper ref and zipper check for patches. Point. So if you have problems with your monitoring plugins, maybe it's good to check if an AppArmor profile is in the way. And best practice guides and monitoring appliance, maybe. I know many had problems setting up that graphing that I showed you. So there will probably be some documentation, even if there's some documentation on the market already how to set that up. Which will try to consolidate that a bit. So make it easier for SLES customers to get the right documentation at hand right from the beginning. And while we are on it, while everything is built in the build service, for me it's just putting some initial configuration inside and then have an appliance coming out for monitoring, including all the details, even might be a good setup for the starting that you can use as base appliance to set up your own monitoring. Let's see. Questions around that? Maybe you want to add something. Open dashboard. I can write. I have my pencil with me.
I'm curious about seeing the SIP creation using live here that not like the ability to have that set up. Is there any way that you can take a look at that? If not now,
just come to me. For that, I have set up my VPN here so we can jump directly on the crazy machines. Okay? So yes, if you want to see the configuration, the only thing that you don't get from me is my password, sorry. Okay. Then at the moment I'm done. These are just some links. I will skip over that. You can read that later on. And as they ask me, if you participate in that presentation here, maybe there are some others that are of interest. You missed most of the SALT introduction stuff already, I'm sorry. But might be a good idea to go to the best practice guides. Check the SUSE Manager roadmap stuff, because you will know a lot of interesting guys there. And of course, SUSE Package Hub will be on Friday.
Will you be looking at making a nice package for customers to see this is like SUSE Monitor? I mean, not like the products that we have already, but like an easy product to you can put into your system and it moves into different via dashboard, really easy for the customers to like semi-pre-cooked. I don't know if you understand.
So,
If you're looking into making a product out of it?
I'm looking to provide first an appliance for you that can easily be powered up, and then you have normally, like if you install Isinga, you will have monitoring of your local host, something like that, but including already best practices like having tempfs enabled file systems and so on, including the graph stuff, Naquis, and all that stuff that is around Isinga. We are currently working closely together with the SUSE Manager guys to get monitoring integrated into SUSE Manager. I don't know if you know that SUSE Manager version 2 had an own monitoring. And I was already poking those guys it doesn't make sense. Because normally you have your own monitoring already set up. So SUSE Manager just needs to inherit all this information from the monitoring. And this is what we currently have. I hope you agree with me. And we are working more on it to get it more smoothly integrated. So it might happen that this gets merged together somehow in SUSE Manager sometime in the future.
If you do that, you can have, for example, SUSE Manager or SUSE Monitor to be like SUSE Manager Lite.
Mm-hmm.
And you can have that as a person to the customer and they see the benefits.
Yep.
And then you can activate the rest.
Yep. Just to give you an idea what we are currently talking about. If you set up a new machine in SUSE Manager, would be a good idea to monitor that from the beginning, right? And if SUSE Manager is orchestrating also Salt, you just need to tell SUSE Manager where your monitoring is, and the rest will be done automatically. So that's the idea. If you assume that this new machine has the role web server or database server, Salt roles come into play. That include also monitoring parts.
For being something you can sell, it's really good to have it because then you can also, as a consultant or a company working with a customer,
show something like that.
They have like 15 or 30 Linux servers and they don't know how to manage them, monitor them, and then this could be like a product for rent it to them or whatever you do.
Point taken. A demo application that can be used, live image, something like that.
Okay, now we have insurance. Someone will sell over it and we can act on it.
Good idea. Yes? Good idea. Other questions? I will be here for the next minutes. Otherwise, you can meet me somewhere here around. Thank you.